Hello one and all, welcome to the Math Magic Show. In this one we're going to take a look at a couple of tricky rationalizations. So I'll try to organize the process so you can learn to do it in a kind of mechanical way. That's the beautiful way in math because it works every time. So what I'm going to have is 1 over the 5th root of 8 as an example. I could use a million other examples. This is just an example, okay? So we can't really do much because you have the 5th root of 8. That's it. So you want to just rationalize it, meaning get rid of the root symbol. So as a first step, what you might decide to do then is simply multiply by the 5th root of 8 over the 5th root of 8. And when you work this out, there's an issue, which is this one. Take a look. In the top, you just multiply across. That's not a problem. You end up with the 5th root of 8 over. And now in the bottom, however, there is a problem. What is the problem? Well, the indexes are the same. Remember that the index is this quantity and this quantity. So for that reason, you just put the root symbol down once with that same index, and then here it says 8 and 8, so you put that there as 8 squared. Why? Because it's like 8 times 8. So again, you put the index once, the root symbol, and then 8 times 8 is 8 squared. So that goes over here. If you look at this, there's an issue, which is that right here, this 2 doesn't cancel with that 5. And you want that to happen because that is how you get rid of the root symbol. So I'm going to work through the same example, but actually improve it so that in the bottom the radical goes away completely. In other words, 1 over the 5th root of 8. And I'm going to zoom in here so we can see everything as I write it. So 1 over the 5th root of 8. And this time I'm going to multiply by the 5th root of 8 raised to x. Why would I do that? Let me finish. You'll see very shortly why. And then 5 and then a to the x. And I want it, just like up here, you see the 2 and the 5 didn't cancel. I want this quantity right here to be equal to the index because then this and this cancels off and the root goes away. So to make that happen, I'm using the x as a placeholder, and then I'm going to proceed as follows. I need to have it so that the x plus the 1 added together have to equal the index, which is 5. So in other words, x plus 1 has to equal 5. You solve that for x, it tells you x equals 4. Once you know that x equals 4, then you can rewrite this more concretely as follows. Get rid of the x in this position here. Okay, get rid of the x in this position and just replace them with 4s instead. So this is now 4, this is now 4. And look at the difference. Because now in the top we have 1 times the 5th root of 8 to the 4th. That stays that way. That doesn't really change. 1 times whatever is itself. 5 and then 8 to the 4th. But in the bottom, we get a different result. The indexes are the same as before, so this still matches this. That's good. So that means you put it there one time like this, so it becomes the 5th. I didn't mean it to be that big. So you still put it there one time, the 5th root of 8, and now it's 8 to the 5th. And the reason is that 8 to the 1st times 8 to the 4th is 8 to the 5th. You add up the exponents. 1 plus 4 is 5. Like that. And the beautiful part is, of course, now this will cross with that, because you have the 5th root and the 5, they cancel off. And all that remains is the 5th root of 8 to the 4th divided by just 8. So this is a way of doing this that is kind of mechanical, because the key is to recognize the following, that whatever you put in this position and whatever you put in this position have to be such that that number plus the other one, the 1 plus the 4, have to equal the index, because then you can make the index cancel with that result that you don't get from doing 8 to the 1st times 8 to the 4th, which is 8 to the 5th. So the exponent that you get at the end, meaning right here, and this cancels the root symbol away, and that liberates the 8, so to speak. Gives you only that and nothing else. Let me zoom out here so you can see all of our work from top to bottom. I've used a relatively simple example, but the same kind of logic applies in most other cases, obviously with some, perhaps modifications when things are a bit more complicated. To keep that in mind. And that is it for this one. Thank you so much for watching and spending time with me. Please leave a like and subscribe. I'll see you in another video.